Hello, math students. Welcome back to our module on linear equations. This is lesson 19, and it is called The Graph of a Linear Equation in Two Variables is a Line. The goal for this lesson is, today we will prove whether points lie on a line or not. The question that I want you to think about is, how do you know if a point is part of a linear equation? All right, so we're going on to our section about things to know, and the first thing that we are asked to do is take the equation that you see below and graph it. And so in order to do that, you have been taught that you need to figure out what your x and y values would be in order to graph it. And so one of the things that we can do prior to figuring out what your x and y values would be is we could turn it into slope-intercept form, and then we can actually draw the line, and then we can determine if those points actually sit on the line that support it. So what we do in order to change it into slope-intercept form as a review, this is a positive 5x, so I'm going to subtract 5x from both sides of the equation, keeping them balanced. That becomes a zero pair, so on this side I'm left with negative 4y equals negative 5x, and the 40 was positive, so plus 40. Then I have to divide everything by a negative 4. So I take that, and then negative 4 divided by negative 4 is a positive 1. Positive 1 times y equals y. A negative 5 divided by a negative 4, a negative divided by a negative is a positive, so I have 5/4 x. And then positive 40 divided by negative 4 gives me negative 10. So now we have this in slope-intercept form, and I can very easily now identify my m and identify my b. So my m in this equation is 5/4, and my b in this equation, if I remember the rule of subtraction, subtraction is the same as adding the opposite, so the b is actually a negative 10. So now I know the two pieces of information that I need in order to graph it. So I remember that I always have to start with the b, because the b is telling me where it crosses the y-axis, and if we remember what that point is called, we'd say it was 0, negative 10. So I go over 0, and I go down to negative 10, and I get to put my first dot, knowing that that's where the line crosses the y-axis. Then from there, it says on the slope that I'm supposed to rise 5, so rise 5, and go to the right 4. Okay, so I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. That's where my new point would be. 1, 2, 3, 4, 5, 1, 2, 3, 4. That's my next one. 1, 2, 3, 4, 5, 1, 2, 3, 4, and it fell off the graph. But you get the idea that that's where my line is going to sit. So now that I have those points, and remember, boys and girls, that all you need is 2 points to create a linear equation or a line on a graph, because you just take those 2 points and you connect to them. So I'm going to use my ID, and I'm going to draw a straight line connecting these points in a straight line. So there's my line that we just discovered, okay? And so then we graphed it like it said, but one thing that we need to talk about in the process is we need to figure out where we have this point 0, negative 10. 0, negative 10, if you notice it, it's sitting on the y-axis. And we know this because it's the b, and we learned that the b is the amount that shows where a linear equation or a line passes through the y-axis. Well, what would happen if we did this? It says, what is the value of x when y is 0? Okay, we know what happens when x is 0, because here's a 0 for the x, but what happens when the y is 0? So in order to do that, what you have to do is actually plug it in. So I'm going to take 5x minus 4 times 0, because it's saying that the y is 0, equals 40. And now we're just going to find out some information. So 5x minus 0 times 4 is 0, so I have minus 0 equals 40. Well, 5x minus 0 is still 5x equals 40, and then I know that x has to be 8. So now I have determined that when y is 0, so the 0 goes in the y spot, my x is going to be 8. And so if I go over there and find that point on the graph, it says that I have to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. 0. Look what I found. Okay, now that's kind of interesting because something monumental is happening. Let's try it this way. We kind of already know the answer to this, but I just want you to see the evidence that supports it. What is the value of y when x is 0? So again, 5 times 0 minus 4y equals 40. So I have 5 times 0 is 0, minus 4y equals 40. Then I know that 0 minus 4y is still a negative 4y equals 40. Divide both of them by a negative 4, and that gives me y equals 40 divided by a negative 4 gives me negative 10. So in this one, we know that x was 0 and that y was a negative 10. And so when we find that, x is 0, y is a negative 10, we found that. So the cool thing that you're discovering by plugging in the values for those numbers is that when you have y as the 0, you have just identified where the linear equation crosses the x-axis. So this point right here tells us where the linear equation in the form of a line crosses the x-axis. Okay, so that's kind of cool. So if you can remember that in your head, when 0 is y, that is telling you where the line crosses the x-axis. Okay, the x-axis. All right, and then when x is 0, that tells you where the linear equation in the form of a line crosses the y-axis. And that would be right there. Okay? So that's kind of major important, and what you need to do is you need to remember when you're given a specific coordinate, you can find where on the line something crosses. So what is the name of the point 8, 0? We're going to call it where it crosses the x-axis, the point that crosses the x-axis. And then what is 0, negative 10? This is supposed to be a negative 10, I'm sorry. What is the point 0, negative 10? We're going to call that the point that crosses the y-axis. Okay, so then the other thing that I want you to try is let's talk about a random point and see if it sits on the line. So what you have to do is, let's say, okay, what if we were looking at 1, 5? So what that means is if you're given a point 1, 5, so we're given the point 1, 5, your job is to decide and see if that point actually sits on the line. So what you have to do is you have to remember this is the x value, this is the y value, so we would plug it in. So we would have 5 times 1 minus 4 times 5 equals 40. And if that's true and it works, then you know that the point sits on the line. So 5 times 1 is 5, minus 4 times 5 is 20, and that does not equal 40 because 5 minus 20 does not equal 40. So this point right here, the answer to that is does not sit on the line. Okay, but could we find one that does without it being a coordinate of 0? And the answer to that question is yes. Okay, so my question is, where is the point that sits on the line if your x value is 1? So let's go with that for just a minute, and let's try it. So if your x value is 1, then I want to know what would be the y coordinate that makes it work. So we know that it's 1, comma, something, so we're trying to figure that out. So we're going to say that 5 times 1 minus 4 times y equals 40. So I know that that's 5 minus a number, right? 4 times something equals 40. And so this is just a logical math thinking process that helps us. So if I say right here, what if your answer was, when you multiply these two together, what if your answer was an answer of 45? So then you have to take 45 and divide it by 4 and see what you get. So this would obviously be 10. And then you have 5 left over, so that would be 4 goes in there 10 times. No, you could do 11 times. 11 times, and that would be 44, and you'd have 1 left over, right? And then we have this, so that's 10, and then that would go in there 2 times, which is 8, which has 2, so that's 5. So we would say 11 1/4. So then you're going to say that the y has to equal 11 1/4. And so if we look on our graph and we check that out, if you go, and it does have to be negative, right, because you have to do a negative times a negative to get a positive. So that means if you go to 1 comma negative 11 1/4, you should be on the line. So let's try it. So we're going to 1 and negative 11 1/4 would be down here. So that, again, shows that that point right there does not sit on the line. So it looks like we did something. Oh, I see what we did, because when you do a negative times a negative, you get a positive, and then that would be 45, which would be too big. So I'm thinking that it would probably have to be 1 comma negative 8 3/4 would probably work if you're looking at your line. So the whole point of checking this basically is just, can you determine where the point would be if it has to sit on the line? And the answer is yes, you can, by doing simple math. This one right here shows that it still does not sit on the line, so you just have to keep working until you find them. So going back for our goal today we will prove whether points lie on a line or not, and if you come up with an answer that doesn't actually sit on the line, then you've proven that those actual points do not belong on the linear equation that you're graphing. If they do sit on it, for example, this one, we have 4 comma negative 5, so when you plugged that in, it would be, let's try 4 comma negative 5, because I haven't tried that one yet. Different color, let's go with this one. So we're saying that we think that 4 comma negative 5 would work. So you're doing 5 times 4 minus 4 times negative 5 should equal 40. So let's check it and see if it does. So this would be 20 minus, that's a negative 20, right, equals 40. And subtraction is the same as adding the opposite. So now you get 40 equals 40. So it is true that 4 comma negative 5 is on the line because your equation was balanced. And that's how you determine if the point that you're seeking is actually on the line. Your equation should balance, so it should say 40 equals 40. And as long as it says 40 equals 40, then you know that that point exists on the line, and that's how you were able to find it. Okay? How do you know if a point is part of the linear equation? The equation, once you plug it in to solve for it, it is balanced, it is equal, it is the same. Okay? All right, kiddos, so that's kind of a fun little lesson to be aware of and to know about. When the y value is 0, then you found where the line crosses the x-axis. Where the x coordinate is 0, you found where the line crosses the y-axis, and that's really important for you to remember that. And then also, to determine if a point sits on a line, you have to determine the coordinates that make your equation balanced. And as long as your equation is balanced, then you know the point sits on it. When your equation is not balanced, then you have proven that it does not sit on there. And we did that too. We call these counterexamples. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.